Hello students, this is an introduction to basic robotics. In this lecture, we will learn about how to make mini projects, right? This is an activity based sessions. You have to work on it, right? So you have to buy some of the equipments related to the robotics, and then you have to engage with that equipments, right? I will show you how to make some of the projects and how to wire them, how to connect them accordingly. And then after I show it to you, you have to be working with that projects, right? So this will be very interesting for sessions. These are very interesting sessions, and you can ask me questions, right? If you have any problems, you can clarify it to me. My name is Nishad. I'm a BSc Engineering Honors in Mechanical and Manufacturing Engineering. I have passed out from University of Ruhuna. I have done several kinds of projects such as automatic plant irrigation system, gantry robot, chili powder grinding machines, line flowing robot, maze solving robots, etc. Those projects I did several kinds of projects, and you can also do and involved in those subjects and projects also, right? We will learn what are the things that we are going to learn in this lecture. This is a basically this is a 1 month course. In 1 month, we will learn about robotics, basic robotics, right? In these sessions, we will look after the following outcomes, right? So firstly, it is an introduction to basic electronics, which means what are the electronic components available and how we can handle them, how we can wire them, etc. Right? Hands-on circuits. Hands-on circuits means you work on that circuits, how to draw schematic diagrams, how to prepare the actual circuits, etc. Right? Then after we will learn about Arduino basics. So basically, in this course, we will learn Arduino, Arduino without programming, right? Because if it is coding, that will be boring, right? So it is also possible for us to pursue the studies without coding, right? There are some of the visual programmings available, so those things we can learn in those areas. Next thing will be a robotic mini project. You have to do a project, right? Whatever the project it might be, I will give it to you, and I will guide you to do the project. You have to submit a robotic mini project to me. And also in my previous classes also, my students did some of the works as well, right? They showed that works also. So if you have any problems, you can ask me, right? Yeah. uh, some One student asked me that will you share the recordings. Yeah, of course I will share the video recordings also, but you have to be available at the class in order to obtain the maximum benefits in this class, right? So next thing we are going to learn will be advanced systems and circuits. Some of the advanced circuits, which means how to control them by using our Bluetooth modules, right? Bluetooth modules means you can control the robots by through our phones, right? Cell phones. We can control. It is also very easy. That also will be codeless, right? So without coding, we will learn how to make those advanced system circuits. Then after, you have to submit another robotic project, which will be preferably it will be a mobile robot, right? You have to control a car, a mobile robot, by using your phone, mobile phone, right? So you can make videos and show it to me, and if it is very good, I will also show it to the class, right? Finally, the robotic showcase or the exhibition. You have to, after we have done those kinds of things, we will say it to the public, right? We can showcase to for other people. So what we will learn, I have a video for you to watch, right? What we will learn, I will share it to you. So this is what we will do, right? You can watch this video. So if you saw this, this is a hand sanitizing equipment. It is a very simple task, right? So it has some of the mechanisms. We can easily make that. Due to the COVID-19, there are several kinds of opportunities available to make innovative projects, right? This is an actually this is an activity-based class, not like your conventional classes. This will be an activity-based. If I teach something, you have to work more, right? If I teach something to you, you have to work more. You have to search something, and you have to buy some equipments, and you have to engage with them. You can watch YouTube videos also. I also have a channel about robotics. I can also share those videos also. So this is a simple project, right? If you can't understand English, I can manage with also Sinhala, right? If you can manage with my English, we can proceed. So this also a simple project, right? Even a grade 6 or grade 5 students can make this circuit. This is not Arduino circuits. These are simple circuits. How we can wire them, how we can connect them. Those things will be discussed in our class, right? So this is also another example, contactless dustbin. So if we, this is a sensor, right? This is a sensor. If we have some objects or some dustbin objects to be thrown into the dustbin, then we can come closer to this sensor, and the sensor activates this motor, and then this will be activated, so the dustbin will be open, right? So these are some of the examples I'm showing you. These are several kinds of ideas, right, that you can work from your home, and you can get more innovative ideas. That is very important. No, it is not essential for us to learn the theory things. We have to focus on the application things, right? So this is an example. These things also we will be discussed in our lectures, right? So how to make a robotics car and control through our mobile phones, right? That will be very much easy. So this car has four wheels, right? So if you can't obtain the four wheels, there are cars also available for three wheels, right? So those things can be obtained in your shops. And finally, we have a robo arm, right? This is a robo arm which can be controlled by Bluetooth or our mobile phone. We can control them, and we can grab an object, and we can put it to somewhere nearby. So that's the end of the video, and we will go for our lecture series, and we will learn about those things. So particularly today's lecture will be a theory class, right? So today we will learn about the theoretical things, and the next classes onwards. Maybe I'm planning to do the classes on tomorrow onwards, though. So I'm planning to start application-wise classes tomorrow onwards. If you are unable to obtain the equipments, we can start from the next week, right? The application classes will be started from the next week, right? So today's class will be focused on the theoretical things, right? So we will learn those things, right? Electricity. What do you know about electricity, right? Electricity means it's like water, right? So what happen if we take a water to the top level, and the water will flow from the higher level to a lower level, right? So what what is the force pushing the water to downwards? And it is the force. It is called a water pressure, right? So same as the electricity also flown, right, from higher voltage to low voltage. right? So if let's say as an example, here we have a battery, right? Here we have a bulb. So in battery, it has the potential, right? Voltage potential difference. So from the positive to negative, the electricity will be flowing, right? So, but on the other hand, the electrons will be flown from the negative to positive terminals. So that is the case that is happening here, right? So as water flows from higher level to lower level, electricity also flows from higher voltage to lower voltage. So in the positive terminal, it has 12 voltage. Say an example, it has 12 voltage. On the negative terminal, it has 0 voltage. So in between 12 to 0, it has a voltage difference, right? So by the voltage difference, the electricity, the current will flow, right? So the force, the water pressure is same as the voltage, right? Here the as the water pressure, the voltage is the main force that pushes the electrons, right? So as for current, we can we can say that current is known as flow of electrons, right? How much is the amount of electrons that are flowing through a conductor is called as as current, right? So this is measured in amperes, but in our robotics case, the current will be in milliamperes, right? Which means 1 divided by 1,000 times, right? So we will deal with small currents. And voltage can be defined as force to push the electrons, right? And we know that the water pressure, right? So force to push the electrons. It is also this. It is measured in volts, right? So in our case, right, in our robotics subject, we will deal with 5 voltage, 3 voltage, 3.3 voltage, 3.7 voltage, 12 voltage, etc. Right? But we have to be aware about, so as you students, you don't have, you should not touch your electricity, right? In your home, it has the voltage supply of 240 voltage AC current, right? So we will deal only 12 voltage, right? Maximum we will deal 12 voltage, right? In your home appliances, the voltage will be 240 voltage, right? So even if the voltage is 240, the current is very much higher. Current will be 13 amperes, right? So here we will deal with milliampere currents, right? On your home appliances, the current will be maximum. Oh, the average current will be 13 amperes. So make sure that you don't touch your home electricity, right? So here we are not going to deal with our home electricities, right? We are going to deal only with the small current and small voltages, right? So you have to be aware about that thing, right? So it is very essential. I strongly recommend that for you to don't work on your home electricity current, right? Just work on maximum 12 voltage battery, DC battery, and you can work on the small items that I have recommended for you to buy. Okay, so keep in mind. Next thing is resistance. Resistance can be defined as the resistance to transfer the electrons through a conductor, right? So we have conductors and insulators. Conductors means it conducts the electricity through it, right? If it is conducting the electricity, it is called the conductors. If it is not conducting the electricity through it, it is called as insulators, right? So as an example for the insulator, you know that wood, right? Wood timber is not a conductor. It is called as an insulator, right? So as an example for the conductor, metals are good conductors. Those things we learned in our grade 6, right? So hope you know that. And the resistance is measured in ohms. Let's learn the basic theories, right? Ohm's law. Ohm's law states that at constant temperature, when the temperature is not changing, right? So, and stable condition, the current is directly proportional to the voltage, right? So we can conclude this as an equation: V is equal to IR. V means voltage, right? Is equal, I means current, right? R is the proportional constant, which means the resistance, right? R means resistance. So in this example, you can see that uh, this is a battery. We have connected the battery and the load here, right? Load means each and every load. Load means we can connect the electronic components such as bulb, motor, sensors, whatever the things we can connect, right? So each and every part, each and every component has its own resistance. So that is why I put R here. So uh, after we have connected to the battery, the equipment is connected to the battery. So how much is the current? So we have to identify how much is the current. So in order to understand how much is the current, can be obtained from the Ohm's law. So we know that I is equal to, so sorry, V is equal to I into R. So if we take I as the main element, then the formula will become as V divided by R, right? So if the voltage is 12 voltage, as an example, 12 voltage, and the resistance is 4 ohms, and the answer will be 3 amperes, right? So this simple formula we can calculate the current, right? So the current will not be available directly, so we have to do some calculations if it is required, right? So next thing is power. Power means how much the energy is required per second to operate the equipment, right? Which is called as power. Power can be calculated by multiplying voltage and current. So also there is another equation is available. P power is equal to 2 times of V, which means voltage can be multiplied into voltage divided by the resistance, right? So this equation also can be used to calculate. So why we calculate power? Because we say an example, we are using a motor, right? 5 voltage motor, right? 5 voltage motor, it has the power of 3 watts. The power will be measured in watts, right? So we use a 3 watt motor. So in that motor, it has the input power and output power, right? So basically, if it is rated for 3 watts, it will be an the output power. So we have to give some input power also, right? Input power means what are the power that we can give, right? So it might be 6 watts. So we calculate these power calculations in order to identify its efficiency, right? So the efficiency will be 50%. So why I put 50%? Because 3 watt is the output and 6 watt is the input. So if we divide these things by this one, output power over input power into 100%, we multiply this and we obtain this as 50% efficient. So this motor will be 50% efficient, right? And then the next formula is R is equal rho L over A. Rho means the density of the material, L means the length of the material, and A is the cross-sectional area of the material, right? So we know these things. And then I also did the example in here, this one, so we can calculate the current, because the voltage is 120 voltage and the resistance is 60. So therefore we can calculate the current by this formula. So the current will become as 2 amperes, right? So next we are going to learn some information, right? There are two types of circuits in electricity. We have two types of circuits. Don't worry about today's lecture, right? Because today's lecture is will be very much focused on the theoretical class, right? Theory part. So it is very essential for us to work on the application classes, right? So that is why we are going to learn theory classes today, right? Just keep focusing on the classes. If you have any doubts, you can ask it to me, right? Okay. types of circuits, there are two types of circuits, open circuit and closed circuit, right? Open circuit means the circuit is disconnected somewhere else, right? It can be disconnected by a switch, which the switch is at in open stage, right? The switch is turned off, so it is disconnected here. And also when we are wiring all the things, there might be somewhere disconnected in wire. So sometimes if there is a worst case scenario and the wire can be disconnected somewhere else, so that is also an open circuit. So if the wire is disconnected, there is no way to pass the electricity, so there is no way to flow the electrons, so the circuit is disconnected, right? Next circuit is closed circuit. Closed circuit means the circuit is completed within itself, right? So in the closed circuit, the current will be flown. And then types of currents, there are two types of currents, right? One is alternating current, second one is direct current, right? So in our home appliances, in our regular home supply, it is alternating current, right? Alternating current means the current will be flowing in two directions, right? As an example, this is a wire, right? This is a conductor wire. In the wire, it is connected to the AC power supply, right? So there is a load, right? In the this alternating current means the current is passing through this wire in this direction, and also after it passes in this direction, it also passes through in this direction also, right? This happens 50 times per second, right? This happens, right, per second. This direction change is happening 50 times, so that is called 50 hertz. So in basic home appliances, we may feel that 240 volt slash 50 hertz, that is also indicated, right? So as I requested earlier, don't work in this current, right? We are not going to work in this current, right? Yeah, of course we can control our home by our mobile phone, right? Even we can control our phone by our voice commands. We can turn off the light. If we say turn off the light, and the light will turn off, right? If we say that turn on the fans, yes, of course those circuits also we can make also, right? But we are not going to learn in this subject, right? Here we are not going to learn, because you students are at grade 8 and grade 9, grade 10 students, so we are not going to learn those things, right? We will learn in advanced robotic courses if it is possible, right? So in basic course we will learn about the small currents, and we will deal in small currents and small circuits, right? Next thing is direct current. Direct current means the current will be flown only in one direction, right? As an example, 5-volt DC battery circuit system, right? Uh, these things, it will be very easy for you to understand these things, right? These are small things. 5-volt battery, and so this is a 5-volt battery. If we take a wire, and if the bulb is connected to the battery, it is called a DC current is flowing in this circuit, right? So this is the DC current. The current will be flown only in this direction, right? Positive to negative direction. But the electrons are flowing in this direction. That is not the case, right? Right? The electrons are flowing in this direction, but the electricity is flowing positive to negative direction, right? Next thing is resistors connections. Yeah. So students, if you have any doubts, or if you can't understand what I'm saying, you can ask it to me, right? You can raise your hand, and I can allow you to ask questions, and also I hear. So I have unmuted you. If you have any questions to clarify, you can ask it to me, right? resistors connection, right? The resistors connection can be divided into two categories. One is series connection and the other one is parallel connection, right? Series connection means the resistors are connected in this way, right? Two resistors are connected each other in this way. And also parallel connection means the resistors are connected in this way. This way means, uh, let as an example, how can you connect these two resistors in parallel connection, right? So there will be a resistor here and there will be a resistor here. So this is called R1 resistor and this is called R2 resistor. How can you connect these resistors, which means these are two loads, right? Two loads can be connected in parallel. How can you connect this? This is very important because in your schools you will learn these things, right? You will learn this is a parallel connection, this is series connection. You will learn these things in your school, but practically you have to learn because you have to practically connect. You have to practically take a battery and you have to practically take two bulbs, right? If you take two bulbs, that will be enough. You have to take two bulbs and you have to connect them in series and in parallel mode. So that way you can understand the informations, right? Because if we connect in series, the bulb will be dimmer, right? If we connect in parallel, the bulb will blink in the same brightness, right? So the bulb will be very bright. So how can we connect, right? We take a wire from the battery and we take a wire from a battery and then the wire is connected in here, right? For one resistance one side, the wire can be connected, right? So then the other resistors terminal can be grounded, right? Grounded means we connect the other resistors other end to the zero voltage end or the ground end of the battery, right? So then after what will you do, right? If you are connecting this as parallel connection, you have to cut down the wire here, which means you have to join another wire, right? So you have to join another wire here and then you have to connect this to the one resistance end terminal. So then after you have to take another end and you have to join in here, somewhere here. So this is the parallel connection, right? And if it is a series connection, how can you connect? If it is series connection, it is very easy, right? So you can connect battery here, right? So you can connect here. You have to take uh, one resistors in and you have to connect the other resistors in, right? On here we connect this terminal to battery, but here we take this wire to connect the other resistors in, right? These things will be discussed in our future classes, right? So what do you know about if I say resistors? So in your schools or in your studies, you know that these are the resistors. Even if I ask A level students how the resistors will look like, they don't know, right? Because they know these things well, right? Because the resistor will look like this. This is how the resistors diagrams, schematic diagrams. They can also say that, but if they give the component, actual component, they can't identify what the component is. So we have to find that. And also the capacitor symbol will look like this, okay? The resistor symbol will look like this or this. And also the capacitor symbol will look like this. And also batteries, or we can say that as cells, the cells symbol will look like this, which the difference between this and this is here we have to draw these two lines which its lengths are equal, right? But in cells we have to draw lines positive and negative. One line is bigger than the other one, right? The bigger line is for positive terminal, right? So this is wrong. We are not going to learn these things, right? We are going to learn is these things, actual parts, right? So the resistors will look like this, right? So this is how a resistor will look like, right? So here the actual resistor has some color codes, right? So it has a brown color, black color, red color, the gold color, right? So these colors are indicating each and every numbers, right? So I will show you in next classes how we can identify the resistor. So what is the value of the resistor? So we are taking that 550 ohm, 5 kilo ohm, right? We take these values. So how we can find these values? So these are the real resistors exist in the world, right? So we have to find the value by a chart. I will show you in the next lecture. And these are called SMD resistors, right? Probably you have seen in your motherboards or in your, if you open up your smartphone, these are the resistors. So if it is look like this one, this is a SMD resistor. This is also resistor, right? So these are also SMD resistors, and this is also a resistor, right? This is called as potentiometer, right? Potentiometer means the resistance of the resistance value of the component can be changed, right? It can be varied, right? From 0 to maximum resistance, right? Let's say if it is 0 ohm here, and this one is 1000 ohms, right? So in between 0 to 1000, we can change the value of the resistors. So these are called as potentiometers, right? So it has three terminals, right? So three terminals means we have to connect a terminal. So this is the positive terminal, right? You have to connect the positive. If you take a battery, you have to connect the terminal positive to this one, right? If you connect here, right? If you connect from here, the other end is connected, and you connect the wire to the ground, and you can set up, right? This is called as a knob, right? So this knob can be rotated, right? So this knob can be rotated. If you rotate the knob, and then the resistance value will be changed, right? So if the resistance value changed to the initial position, which means this one, the knob is changed to this one, it will give uh, the minimum resistance, which means somewhere 0 ohms, or somewhere the minimum value can be obtained, right? So if you change the resistance to maximum, so that can also be obtained, right? On the other hand, you can also wire the resistance by wiring the positive terminal to common. This is called as common, right? So you can also wire this one to this negative terminal also. ඔයාට මේකටත් කනෙක්ට් කරන්න පුළුවන්, බැටරි එකේ ග්‍රවුන්ඩ් එකටත් ඔයාටත් කනෙක්ට් කරන්න පුළුවන්. ඔයා මෙහෙම කනෙක්ට් කරා නම් මේ කරන්ට් එක මෙහෙම එනවා, හරිද? බැටරි එකේ පොසිටිව් ඉඳලා කරන්ට් එක ගිහිල්ලා මෙහෙම එනවා. එතකොට ඔයාගේ අනිත් පැත්ත තමයි සර්කිට් එකට එන්නේ, හරිද? එතකොට ඒක තමයි මේ වෙනස් එක. මෙතන 2 ටර්මිනල්ස් තියෙනවා නම් ඒකේ වෙනස් එක මෙහෙමයි. The next thing is capacitors, right? So why do we insert resistors? We insert resistors for the purpose of reducing the voltages, right? If the voltage is higher, it means you have a 12 voltage battery, right? You have a 12 voltage battery, and on the other hand, you have a 5 voltage LED bulb. So how will you connect these things, right? If you connect them directly, your LED bulb will be broken up, right? Your LED bulb will be defected, right? So we have to put a resistor in between the battery and the LED bulb. So that is the case we are using resistors, right? So hope you understand why we use resistors. And capacitors, these are storage devices, right? As similar to the batteries, these are storing the electricity current temporarily, right? If the battery is disconnected and if the capacitors are available, and it can produce current to the circuit, right? Temporarily. So these are temporary storage devices, right? And these are SMD capacitors. These capacitors can be found in your electrical devices, which means your radio or TV, those kinds of things. And these capacitors can be found on the small circuits, which are smartphones or laptops or computer motherboards, etc. These capacitors are called as SMD capacitors. These are can be found from those electronics components, right? So hope you know that. And these are also capacitors. The normal capacitors are available in the market, right? Next thing is batteries, right? So batteries will look like this, right? So positive terminal will be indicated at the positive terminal, and the negative terminal will also be indicated, right? In batteries, we can connect batteries, right? So one battery, it is not a problem. So if we have two or more batteries, we can connect them in two ways, right? The one way is series connection. So series connection means we take the positive terminal of the battery and then we connect the positive terminal to the negative terminal of the another battery, right? And then we again take the positive terminal of the battery and connect the negative terminal. So likewise, we connect these batteries in series mode. This is called as series connection of the batteries, right? Not the resistors, series connection of the batteries. If we connect these batteries in series connection, the voltage can be increased, right? So if we let's say as an example, we have 1.5 voltage battery, right? And also another 1.5, 1.5, 1.5. So totally, if we connect them in series connection, the total voltage will be added. So the total voltage will be in between this terminal and this terminal will be 6 voltages, right? And on the other hand, if we connect these batteries in parallel connection, right, this is called as parallel arrangement. If we connect the batteries in parallel arrangement, we have to connect the positive terminal to the other battery's positive terminal, and then we have to join another wire and take it to another battery's positive terminal. Likewise, we are connecting like this, right? And also similar for the negative terminal also. If we connect the batteries in parallel connection, the voltage will remain same. So if the battery has 1.5 voltage here, 1.5 here, 1.5 here, also in between these terminals, the voltage will be 1.5 voltages. But why we connect like this? We connect because if we connect like this, the current will be added up. So the battery will give 2 ampere current here. Example, the battery will give 2 ampere current here, 2 ampere, 2 ampere, right? So that means we can obtain 8 amperes of current. Maximum 8 amperes of current we can obtain by having 1.5 voltage. So that is the difference. But here we can't get the current, right? Here we only get 2 ampere current, but the voltage will be higher. So same as the power will not going to change. So if you have any doubts, what I have done so far, you can ask it to me, right? So if you don't have any doubts, we can go for the another slide. So next electronics components that we are going to see is relays, right? Relay means this is also a switch, right? This is also a switch. So this is the schematic diagram of a relay, right? Which means in engineering purposes or in scientific way, we use these diagrams to interpret our circuits to other people, right? So, but basically in real time, a relay will look like this, not look like this. This is this is called as a relay module, right? Because this board, this particular electronic board is called as a module. So this is relay. right? This part, this only part is called as relay. In a relay, we have two separate circuits. That is the a special thing of the relay, right? We have two separate circuits. The one circuit is for small voltages, right? Small voltages means we can have a 5 voltage circuit on one side, and also even we can have 240 voltage AC current on the other side. So that is called as that component can be called as relays, right? So here I highly recommend you that don't work on 240 voltage ACs, right? But what we will do in robotics, we will learn how to wire 5 voltage. Here we will use 5 voltage in this direction, and we will also use 12 voltage, right? Instead of 240, we will use 12 voltage DC current in order to operate our motors, right? So we will learn those things in next class. And here if you see that each and every component has to be powered. So as an example, uh, if you are going to switch on the TV, or if you are going to change the channel of your TV, what will you do? You have to in your remote, you have to put a battery to operate the remote, right? You have to give a power to the remote, then after the remote will send a signal to TV, and then the TV will change its channels, right? So we have to power up. That is basically I the term I use will be power up, right? Power up means we have to give a power, which means if we have a smartphone also, we have to power up, right? So likewise the relays also have to be powered up. Power up means we have to obtain a battery, and then we have to power up, take a positive terminal, and then we have to connect the positive terminal here, right? We have to give positive 5 voltage to V in. So if you analyze the relays, there will be indication VCC, right? VCC means you have to give a power to the component, right? You can write it down VCC, right? So then what we have to do is you have to connect the negative terminal to ground, right? So which means the ground has to be grounded on the battery also. So if we connect these two wires together in between the battery and the relay module will be activated, right? Which means this green light will be turned on, right? This green light will be turned on means the relay module is powered on, which means you have turned on your smartphone, right? Likewise. After that, there is another pin called in. In means input, right? Input. Input means if we have a sensor, right? Sensor is, let's say we have an IR sensor, right? IR sensor detects the object nearby. So in previous video, අපි video එකේ මේ දකලා තියෙනවනේ අර sensor එකේ ළඟට අපේ අතේ ළඟින් අරගන්නවා නම් මේ අර ඩස්බින් එක ඕපන් වෙනවනේ. ඒ වගේ තමයි IR sensors ඒවා වැඩ කරන්නේ. හරිද? අපි මොකක් හරි ඔබ්ජෙක්ට් එකක් මේකෙන් ළඟට මේ අරන් එන්නේ. හරිද? ඒක අරන් ගත්තාට පස්සේ මේ ඒකේ ඉඳලා සිග්නල් එකක් එනවා අවුට් එකට. හරිද? ඒකේ වයර් එක හරහා අපි අවුට්පුට් එක ගන්නෙ. ඒ කියන්නේ මේකේ සෙන්සර් එකේ අවුට්පුට් එක. හරිද? අන්න අර අවුට්පුට් එක අපි මේ සම්බන්ධ කරගන්න ඕනේ මේ රිලේ එකේ ඉන්පුට් එකට. We have to connect the sensor's output to the relay's input. So in this manner, the relay is, which means the relay on the one side is powered up, on the one side is connected, right? On the other side, right? On the other side means this side. So this side we can connect several objects, right? As an example, we can connect a motor, right? So if there is any object comes near the relay, near the sensor, then the motor has to be operated, right? So then what we have to do is we have to wire on the other side. Other side means, so there is a motor, right? So on the motor, it is operated in 12 volt. Say an example, okay? The motor will be operated in 12 volt. So we have to take a 12 voltage battery, right? We have to take a 12 voltage battery, and then we have to take this power, right? Positive terminal has to be connected on the common terminal. If you see that on the other side of the relay, it has C or com කියලා ගහලා තියෙනවා. රිලේ එක අනිත් පැත්තේ කොම් කියලා එක ගහලා තියෙනවා. හරිද? ඊට පස්සේ මේ වගේ ඩයග්‍රෑම් එකේ ඔයාට පේනවා ඇති මේ වගේ if you take a relay මේකේ පේනවා මේක normally close කියලා. ඒ කියන්නේ NC කියලා ගහලා තියෙනවා ඒකේ. හරිද? ඊට පස්සේ අනිත් පැත්තෙන් ඒ කියන්නේ මේකට රිලේ එකේ මේ ටර්මිනල් එකට මේ ගහලා තියෙනවා NO කියලා. හරිද? NO කියන්නේ normally open. හරිද? මේක මේව මොනවද කියලා අපි බලමු දැන්. මේ common, if we connected the common terminal, battery's positive terminal is connected on the common terminal, right? On the normally closed terminal, we have connected to the motor, right? On the other motor's other end, the motor's other end is connected to the battery's negative terminal. So that means the circuit is already completed because the common and normally close are already connected inside the relay, right? Inside the mechanism, those are already connected. So what will happen is the motor will be turned on already, right? The motor will be continuously rotating before the sensor detects the object. ඔයාට මේවා තේරෙනවා ඇති මම හිතන්නේ මේ සෙන්සර් එක අපි මේ මොකක් හරි ඔබ්ජෙක්ට් එකක් මේ ළඟට අරන් ගන්න කලින් මේවා මේ මෝටර් එක කරගෙන තමයි කරකවන්න තමයි තියෙන්නේ. ඒ කියන්නේ මේවා already they are connected, right? So that is the case. If they are already connected, the motor was rotating, right? So what will happen if as an object is come near the sensor, the sensor will give a signal to the relay, right? That means there is a signal I have obtained. So then the relay will disconnect this one, right? So disconnect this terminal, which means this will disconnect this one, so that the motor will be turned off. So that means as a conclusion, if the object is near, the motor will be turned off if we connect common and normally closed terminals, right? On the other hand, right, on the other hand, we have a battery here and we have a motor here, right? We have the positive terminals are connected on the common terminal, and also the normally closed terminal is connected to the motor, and the motor's other end is connected to the ground, right? What will happen is, if we, in this case, the motor in the initial position, the motor is turned off, right? Because there is no current is flowing through the circuit, right? So there will be no current flow, so there will be no motor is running. So if we have an object near to the sensor, and then the sensor will give a signal to the relay, and then the relay will be activated. So these two terminals will be connected by the relay. Mechanically, these two things will be connected, right? You can also search how a relay works in YouTube. In detail, you can go for what is happening inside the relay also, right? So we are not learning those deep things because those are very engineering things you can see. So we are learning the applications of relays, right? So if we connect common and normally closed terminals, then the circuit will be connected after the sensor's input is come to the relay, right? So then after, the motor will be rotating. So this is how they have made the dustbin system, automatic dustbin system, automatic sanitizing systems also done. This is the technique. We can even use relay. So did we code here? No, we didn't code here, but we do is we connect the relays, right? So we only need a relay and a sensor and an actuator. An actuator means a motor, or it might be a bulb, it might be a pump, etc., right? So this is the simple case. So next thing is transformers, right? Transformer means it converts the voltage, right? It means if we have a voltage, let's say that we have a 240 voltage AC here, and then these transformers will give on the other circuit, on the other side we can get 112 voltage ACs, right? Or even we can get, according to the number of circuit it has inside, we can get different values, right? But for a particular transformer we can't change it, right? But there are also variable transformers also available, but in a particular transformer we can't change those values. But the voltage can be increased or decreased by using transformers. And also, on the other hand, if the voltage is increased, the current will be decreased, right? In total, the power will not change. If we have 20 watt in here, and also on the other circuit also we will get 20 watt, right? We can't change the power, right? So that is the case. And the next thing is fuses. Fuses are used to disconnect the circuits, right? We know that there are two circuits, open circuit and closed circuit. We use fuses to disconnect the circuits. Disconnect means if the circuit, let's say you have a sensor which is cost about 1 lakh, right? So you have 1 lakh sensor, and the sensor is rated for only 5 ampere current, right? But we are using the currents more than 5 ampere. You expect that the current will be very much higher, so you have to definitely put a fuse which is rated for 5 amperes, right? So what happen if the current is exceeded from 5 amperes, the circuit will be disconnected, which means the fuse will be cut off. The fuse means we can replace the fuse for only 5 rupees, right? So we can easily disconnect and throw the fuse, and we can put a new fuse after we have corrected the problems, right? So that is the case. We are using fuses in order to protect the circuit, right? We are using fuses for protecting the circuits. And also these are also fuses, but this is an SMD fuse. SMD fuse means in electronic components they use these fuses. Also in if you want to repair your electronic device, you have to go and check the SMD fuse, because this is the component that usually fails, right? So if we replace the fuse, the most probably the component will work, right? So you don't have to change the component, which means you don't have to change your electrical device, right? Which means you don't have to change your phone. Only you have to change 5 rupees fuse, right? So the next thing will be switches. So there are tons of switches available in the market. You can obtain what the switch is doing. Switch basically has 3 terminals. I'm not going to discuss those in deeply, but the switches, this switch has 2 terminals, right? So which means we have to connect the positive battery terminal to this terminal, and you have to take this switch and another terminal to a bulb, right? And then you have to take the bulb's negative terminal to the battery's negative terminal. So if we connect like this, if we turn on the switch, and the bulb will be turned on. If we turn off the switch, and the bulb will be turned off, right? Similarly, as relays, right? The switches also having 3 terminals, right? If your switch has 3 terminals, that means that can be called as C, which means for common, and normally open and also normally close, right? You have to find what are the terminals, right? Then after you have to wire accordingly. So we have to here we have a bulb, right? So we have a bulb here. So what we have to do is we have to take the positive terminal and you have to connect it to the common means most probably in the center, right? So center we connect the battery, right? Then after we have to take, we have to wire for normally closed, right? Normally closed terminal, we get the wire and then we connect the wire to the bulb, and then the wires, the bulb's ground will be grounded to the battery. So what will happen by this wiring diagram, the bulb will be already turned on because the switch is connected for common and normally closed terminals, right? So the bulb will be already turned on. So if we connect on the other way means you connect the positive terminal to the common terminal and then you get another terminal, which means the normally open terminal, and you connect to the bulb and then the bulb's ground will be grounded to the battery. And this method, if you turn on the switch, then only the bulb will be turned on. So hope you understand these simple things. If you, no matter if you don't understand me, just ask me. If you don't understand me, I will retell it to you. So if you can't understand, you can ask me. So AC adapters are used to obtain voltages in small amounts, right? As an example, in your smartphones, you are using 5 voltage charges, right? In these are smartphones are charged by DC. So in if we take this adapter and inside, right, which means there is a hole inside. Inside it has a 5 voltage, right? On this surface, which means this surface, it has 0 voltage, right? Which means this is a 5 voltage DC and this is a 0 voltage DC, which means the ground, right? So but what we give to the adapters is different, because we give we connect these terminals to our home supply, right? Home supply means AC supply. So what the adapters do is they are converting AC to DC, right? They are converting AC current to DC current, AC power supply to DC power supply, but also they are increasing or decreasing the voltage values, right? They are also increasing or decreasing the voltage or current values. That is called AC adapters. But there is another component which is also available in the market. It is called as voltage regulators, right? Or we call as buck converters. Buck converters means uh, it has 4 terminals, right? In this terminal, we can connect 12 voltage and ground, right? We can connect here, and also on the other side, we can get 5 voltage and ground, which means we didn't convert this AC DC connection, right? We only obtain 12 voltage from, we only obtain 5 voltage from 12 voltage. This is called buck converters, right? We will use these buck converters, right? Probably we will use these buck converters for our robotics projects if it is needed, right? But these are somewhat different because these are AC adapters. These are converting AC current to DC current and also providing increment or decrement in the voltages also. So the next thing we are going to we will have we will be involved in these diodes also. So diode means there are 3 types of diodes we will use in robotics, right? Basically the normal diode. The normal diode means it restricts the flow of the current in only one direction, right? It will only allow the current to flow in one direction, right? It means the resistor will, sorry, the diode will allow the current in only this direction. If we connect the diode on the other side, right, on the upwards down, which means if we connect the diodes on the other terminals, the circuit will be disconnected. As an example, if there is a battery and we have a diode, right, here we have, let's say that is a diode, and then there is a load means bulb, so, right, so then the bulb is connected to the ground terminal. If we connect only correctly, then only the bulb will be turned on. If we connect the bulb on the diode on the other direction means uh, left to right, it will not, the bulb will not be turned on, right? So those things we have to consider. So that is, in several places we can use normal diodes to restrict the flow of the current for that direction, right? So hope you know that. Then the diodes category, there are LDR diodes. LDR means light dependent resistors, right? So this can also be named as light sensors, right? So if we apply a light here, so as an example, if you apply a light here, the illumination will be recognized by this photosynthetic uh, surface. Then after, there will be a current flow from these two terminals, right? So are you thinking about any idea by learning this LDR? So what happen if you can build a circuit or build a project or build an invention, that if your father has come to your home, and then the gate should be open, right? So what happen if your father has to come uh, on the door, and then he has to turn on the headlights, right? After he uh, turned on his headlights, the gate will be automatically open. So these are the simple things, simple ideas we can grab from the theoretical classes, right? So this simple invention can also be done by you, but don't work on AC currents. But we can also simply work on those kinds of projects. If you have an LDR, you can work on simple projects, right? So light dependent resistance. And then we have LED with LED. This is also a diode, and LED means light emitting diode, right? Light emitting diode means it has a positive terminal and a negative terminal, right? If the pin is too long, it is positive, right? If the pin is shorter, it is a negative pin. So if the battery is connected to the positive and then the negative, which means it has a voltage difference, right? If the voltage difference is there in between the bulbs, and the bulb will give light. So this is how LED works. And transistors, these are some kinds of transistors available in the market. And why we use transistors, we will not going to use these transistors in our projects. uh, Transistors are basically used as a switches, right? As relays. In the relays, it has transistors, right? uh, Also, the transistors can also be used as regulators. Regulators means we can uh, increase or decrease the voltage values, right? Next thing will be solar cells. Solar cells means it can produce, this can be worked as a batteries, right? Battery means battery is a power supply to a circuit, right? Same as the solar cells can also provide power to a circuit. But in especially solar cells can be uh, can give power to a circuit by obtaining light from the environment, right? Not heat from the environment, but light from the environment. If we place a solar panel in the lighting environment, if there is any illumination available, and then the solar panels will give the voltage, right? So in between, so the solar panels can also be used as batteries also. And integrated circuit means IC, right? IC means uh, is also similar to transistors. So it has transistors inside, and these ICs can also be used to control the circuits, right? So basically, if let's say that we have two sensors, right? We have two sensors, the LDR sensor and then IR sensor, right? Then we have to operate a bulb, right? We have two bulbs, right? Let's say that we have a red bulb and a blue bulb, right? So if one sensor is activated, we have to turn on the red light, right? If the another sensor is activated, and then the blue light will be turned off. So this is the criteria. So in order to work according to this criteria, we have to control the circuit. We can't connect them whatever we want, right? So we have to control the circuit. In order to control that circuit, we can use integrated circuits. So that is why we use integrated circuits. But also, without using these integrated circuits, we can go for some advanced circuits. Advanced circuit means Arduinos, right? Which means this, right? These are the controllers. That means some of the advanced controllers, because it has ICs inside, right? ICs are having transistors inside. Arduino and PIC, Raspberry Pi, these controllers are having ICs inside, right? So hope you know that. And basically we are having four different controllers, right? PIC, which means programmable integrated circuits, right? PIC is a controller that is used to control by using a program. We can code by using a micro C language, and then we can control a circuit. Right? If you have two sensors and if you have two outputs, and then we can control those by using PIC. Right? And also we can control by using Arduino. Right? We will learn what is Arduino, right? In upcoming lectures, we will learn what is Arduino, how we can connect them, how we can wire them. Practically, we will learn those things, right? And also Raspberry Pi. This is an advanced one, right? Because why I say this is advanced, Raspberry Pi is a small computer, right? Computer means it can be connected to a camera, right? It can be connected to a keyboard. It can also be connected to a mouse, and it can also be connected to a monitor. So both those things we can navigate through this Raspberry Pi or operating systems environment, right? So we will learn those things also in future. And the finally the controller is available, readily available, is programmable logic controllers, right? These controllers are used to do advanced robotic systems, right? Which means if you want to design an actual system, let's say as an example, you are going to design a machine which produces masks, right? So automatically it produces masks, right? So we have to go for the PLC programming controller, programmable in logic controllers, right? So an actual large scale machines, we have to use these programmable logic controllers, right? But keep in mind that these controllers, such as Arduino, Raspberry Pi, PIC controllers, these controllers are for temporary projects, right? We can only do for small, it has a low durabilities, right? We can only work these controllers for small amount of time, right? We can't run controllers for longer years, right? Years and years we can't operate. But in programmable logic controllers, we can work, it has more durabilities, right? We can have even more than 20 years, right? Those are the difference between them. And then Next thing is types of Arduino. So because the lecture is 1 hour today, we will wind up the class. If you have any doubts, we will clarify, and on the next lecture we will learn about Arduino, how to wire them, how to navigate them without programming, how to install the Arduino software. Hopefully, I hope that you all have a computer to access so that you can upload the Arduino codes to the Arduino. So don't worry about how to code, right? Because you are students. I have an alternative method to program Arduinos by visually. It will be like playing games, right? So it will be like playing games. You can also code the Arduino without coding, which means the visual programmings are available. I will show it. I will show you how to do them. If you have any doubts, you can clarify. I will upload the video. Also, we will form a group in WhatsApp. So on the group, I will upload this video for you. If you have any doubts, you can clarify to me, and hopefully you all got the equipments with you in next classes so that we can learn together very easily. Uh, so, do you have any doubts to clarify it to me? Even I don't know your names, right?